Very good evening to my respected teacher and my fellow classmates. I am Charya from Techno India University. I am a first year undergrad student. I have been given the topic sparse matrix representation. So, first we define what is a matrix. A matrix is a two-dimensional array of data having m rows or n columns, and then its dimension is defined as m by n, which is written as m cross n. And a matrix in which most of the elements are 0 is called a sparse matrix. In contrast, if a matrix has most of the elements non-zero, it is called a dense matrix. This can be calculated using a formula which is written as the number of zero valued elements divided by the total number of elements. In the example here above, we see that there is a matrix which is a 5 cross 4 matrix having total number of elements equal to 20 and the number of non-zero elements equal to 8. So therefore the number of zero elements is equal to 12, and hence sparsity is equal to 12 by 20, which is 0.6 or 60%. Now the question arises, we already can represent a matrix, a normal matrix. Why do we need to use a sparse matrix? Well, sparse matrix has certain advantages. First is it takes much lesser storage in comparison to a normal matrix because most of the elements are in it 0. So the zero elements are easily ignored and the non-zero elements are emphasized on. Also, it takes much lesser time to compute anything in it because most of the elements are 0. If an appropriate algorithm and programming is built, then calculation time complexity and the storage space complexity is much lesser in a sparse matrix in comparison to a normal matrix. Next, we have types of matrix. Mainly there are three types of matrix. Lower triangular matrix, in which the elements above the diagonal are 0. So therefore the elements which are non-zero occur below the diagonal elements. Therefore it is a lower triangular matrix. In upper triangular matrix the opposite happens, which means the elements below the diagonal elements are 0. In tridiagonal matrix only the diagonal elements are non-zero, rest of the elements are 0. So the non-zero element doesn't mean that it would only be the one diagonal. The immediate above and immediate below the diagonal elements are also non-zero. There are various real-world applications of sparse matrix, which is very astonishing. So the first and foremost example is in our social media connections. We all use social media apps, Facebook, Twitter, and we have lots of friends. But if we see and think, contemplate on it, we'll find out that in comparison to the total number of people, users on Facebook or Twitter, the number of people that we are connected to is much less. So this can easily represented by a sparse matrix. Next, another example is a documentation, natural language processing, in which from a vocabulary only hardly a few of the words are documented. So leading to a matrix with mostly 0 counts. Another vivid example of real world application of sparse matrix is Netflix. Recommended user interaction matrix, in which we all know about Amazon product purchases, Netflix movies, ratings. We all watch movies, and Netflix is one vivid example of an app where all those wishes are fulfilled. Now, in these apps, hardly a few users purchase in comparison to the total number of people in it. So most users have not even rated or purchased items, so the matrix is usually empty. Another example is in web search and page rank algorithm. So Google's web indexing also in link structure between pages. In comparison to the total number of pages available in Google, while we search, only the pages that is related to the search occur, and from them only which are like highlighted more is selected by the users. So most of the web pages are not present in the search, so this can also be represented using a sparse matrix.